Droogs. This is the Alex Manassa, and we are continuing on with the AmeriChete project. I am building the circuit board that's going to have the LED driver. I decided to just go ahead and nix the whole MOSFET with a resistor to regulate the current. That was just dissipating tons of wattage, and it was just a huge waste of energy. Big problem. Don't want to do it. Forget about it. It's gone. Okay? So instead, we've got ourselves this. And I'll give you the schematic, which is a little easier to read. The reason why we use schematics is because they're just easier to read, to understand the electrical connections themselves, right? So I believe I laid this out last video. You've got your RGBW LED right here, which is just an RGBW LED just has an LED that has an R, a G, a B, and a W part. We've got our connector to get our power and control. We've got our accelerometer, which I threw on there. You don't have to populate it. But if I want to go ahead and practice and have an accelerometer on there, do some software development with that, I would like to. I really want to get into that software algorithm and start doing Runge-Kutta integration methods, okay? We also have each of our individual LED drivers here. The red one, R01, G01, B01, and W01, okay? Now I named it 01 because I was going to have all of them on one board. I decided that that entire architecture is just absolutely a terrible idea. Sometimes you got to admit that an idea is terrible. Now here's the circuit board. You can see here, I'm going to go ahead and just make all these layers invisible except for the ones I want to talk about. There's probably a faster way to do this. Okay, so only... Huh, that's weird. Oh, okay, that's probably... I don't know if that's the drill layer or what. What layer is that? Huh. Well, anyways, only the top layer is enabled right now. Apparently, there's also the drills are also there. Don't know why. That's okay. Whatever. It is what it is. Oh, yeah, that's through-hole pads. Okay, got it. Okay, so here's our circuit board, right? Here's the accelerometer right here. Here is the first circuit, and I'm going to turn the front and back on. Here's our first circuit. You can kind of see it there. That's one of the drivers. Another driver here, another driver here, another driver here, and in the middle is our RGB LED. This is a big board. I think it'd be nice to be able to like compress this down a little bit, so I'm going to work on that. Get this thing nice and compressed. Now that it's laid out, it's going to be a little bit easier to do that. We've also got... Get out of here. We've also got... let's see... Oh, you know what? You know, it's easier. Just do that. So here's a 3D render of the board right now. So it's a little bit easier to see what's going on the top side and the bottom side. So here you have your LED driver chip. You got your big old inductor here. Your inductor's gonna pump up the voltage for you because if you the more current you shoot through an inductor, you're gonna start slingshotting the voltage upward. In a switch mode power supply, yeah, we can make this a lot smaller. All right, very cool, very cool. Now, if I wanted to have this... Now, what I'm going to show you in this video is how to finish up a circuit board, okay? So you'll notice that there are little spaghetti wires still here. So there's still things that have not been routed. There are also could be design rule errors. This little bug up here, perform design rule check. You can click on that and then hit run DRC. Design rule checks, and now it says it's got a few errors here. It's got pad too close to pad. And you can click on these to see where they are. Okay, so all right, we got a little, all right, so all the accelerometer pads are too close to each other. Okay. And let's go ahead and list the unconnected as well. So here's an unconnected item down here. It's hard to see. In fact, I don't see it. Oh, there it is. Yeah, it's this guy right here. Oh, you see that tiny little line? Some of these are tough to find. All right. So you got that one, and there's this one. So I got two connections I missed, which is pretty common. It's really hard to make sense of what's going on here. I'm going to grab my route tracks tool, hit it, drag it out. Now that I've laid down that track, I'm going to hit via. Via is being dragged around in weird spots for some reason. I'll just put it. Oh, okay. It's jumping past this guy. Okay, I see. Well, I don't want that. So let's just delete. Let's go back. Delete. Delete. And I'm going to hover over this wire here. So what KiCad is trying to do is actually trying to do avoidance for me. I want to drag this away just a little bit so I have some space. So I'm just going to put my mouse over it and hit D, and it'll let me drag it. Let me zoom out a little bit so I can get a bit of a bird's eye view here. All right, there we go. There we go. Now, I've got this copper pour area here as well. So I made a copper pour, or it's called a copper fill in this. You have to update the graphic by hitting B. That'll update all. So now you see that it's moved. Now you see that it's moved. Now I'm going to go down here. I've got plenty of space now. I'm going to go ahead and route this track. So you go out here. I want you to make a via. Boom, there's the via. Now I'm going to click on the via. Now that I'm on the back side of the board now, I want to flip. Or sorry, go to page down. Oh, sorry, page up. I was already on the back side. So page up or page down will toggle between the different layers of copper you have. Right now I only have two layers of copper, one on top, one on bottom. In fact, actually, I'm going to just backspace that. Update, okay, because I'm just going to go directly from here back to here. No reason to get complicated. Hit B again. There we go. Now this guy up here, he needs to get routed as well. He's on the back of the circuit board, so I'm going to hit page down. Now I've prioritized the back of the board. The back of the board is green, if you hadn't noticed. And I want to drag this guy out, and let's make a via right here. I think we're going to have a really easy time if I just put a via right there. All right, that is done. Go back up to the top of the board with page up. This is going to be easy. Just grab this. All right, now notice all of the pins that are connected to this are highlighted right now. So I can take it over to here, I can take it over to here, I can take it over to here. It's up to you. I'm going to put it right here. This is a DC, more or less DC signal. I don't expect there to be like rapid switching on this. There's no reason to get really anally retentive about your routing. I mean, it'd be the perfect place would be to put it right along the line here. Ah, man, now it's bugging me. Years of doing this have done this to me. There we go. Yeah, see, that wasn't so hard. Hit B again. There you go. Looks great. Love it. I'm going to make this just jut out a little. Oh, no. All right, doesn't want to do that. Okay. We don't have to do that. B again. There we go. Looks pretty good. Now, all the silkscreen pieces are in the wrong areas, and I can tell because if I do Alt 3 and look at the 3D view, U1 is printed on some copper, right? That's no good. I've got U4 on some copper, so I got a general mess over here. All right. So on the right here, you can check off and enable and disable different layers. So let's just go ahead and focus on the front right now. I'm going to just have the edge cuts of the board. So I got the edge of the board. I want the front silk screen, okay? And I'll do the front solder paste too. So front solder mask right there. That way I can see where the parts are. This is definitely something you want to do. All right. Let's go ahead and place everything on the top of the part. Okay, there's D1. Let's move that. There we go. Very good. Anywhere that doesn't have solder mask, so anywhere that isn't purple right now, is a good spot. Cat is begging for attention again. Quit your begging. Quit your begging. It's that needy cat. I was told cats were aloof. This cat is not. He wants attention. All right, I'm going to put this guy. So I'm going to start making a convention of top or to the right. Just make it pretty. Just make it pretty. Things that are pretty tend to be very clear. Here's U4. Let's put you over here. Okay, let's put you up here. Keep that convention going. We're looking good. We're looking good. All right. I guess in this case, I'll put you below. That'll be okay. What's going on here, right? Ah, there it is. Sorry, it's my phone. So whatever you click last is going to be the top layer, the active top layer. So you're going to want to make the active top layer here the silk screen, so you can grab the silk screen. Everything's... All sorts of distractions tend to pop up while you're doing work. That's okay, though. Let's put you on top. Now, see how on these connectors, pin 1 is a different shape? That's how you know it's pin 1. It's a good guide to show you like how to solder this thing together. It's little subtle cues like that which are very helpful for the circuit designer. All right, so all the reference designators are here now. I'm gonna just move this J2 down a little bit. All the reference designators are here now. I would like to see what I can do about what's on the fab layers. All right, so these fab layers, there's a lot of information on the fab layers. I think I'm going to leave them on there. I think what I'm going to do is I'm going to have a sheet that's my bill of materials, and it's going to tell me what C1 is and versus R13 and that sort of stuff. Okay, let's go ahead and do the back of this board now. All right, 1 second. Hello? Yes. Yes, you are. Okay. I'm not looking for work right now, but if you have a job listing, feel free to email it to me. I am not. I'm not right now. All right. Thank you. All right. Bye. Oh, I don't know if I'm going to cut that out of the video or not. I get like 2 or 3 of those calls a day with job like, hey, would you be available to do this job or something? I don't care. I don't want to do your job. I don't want to. they use these really out of date resumes. And it's just, oh my gosh, it's the worst. Never use your primary email address to look for a job. And never put your real phone number. Get a burner phone. Looking for a job is a lot like being a drug dealer, I think. These people who can barely pronounce my name are constantly calling me. Even though it pretty clearly lists on my LinkedIn that I'm not looking for work. They're just persistent. You can tell that they're from some sort of like job mill or something. They usually have some contract position. It's usually out in California because California is hemorrhaging employees like crazy. Oh my gosh. It's like, I do not want to go to El Segundo for a 6-month contract position. I'm not looking for the best way to find a job is to do word of mouth. Like honestly, if someone recommending you, that's the best way to find a job, because that's a vote of confidence that they think that you're a good fit. So not only does this person who actually knows you think that you'll like the job, they think that you're also a good fit for the job. So it's a win-win in that case. All right, everything's looking pretty. Let's take a look at this guy. Alt 3, boom, here we go. Look at that. That's a beautiful board. Things look better. Things look better. You know exactly where the part number is. If I stuck like U2 and C2 and D2 in the center here or something like that, or L2, you wouldn't know what I was talking about. It would be a hot mess. You don't want a hot mess. Circuitry is already hard enough. You want to make things as easy as possible. I really like this 3D tool. Let's go ahead and flip to the back and see what we see. It takes a little bit of practice to get good with this 3D tool, but it's not so bad once you figure it out. See, now this is printed on a VIA. That could be an issue. So that's the sort of stuff I'm checking out. That one's on a VIA as well. I think we'll still be able to tell what it is. Not optimal, but it's okay. All right, now about those DRC issues. Let's get back to that. We'll fix that, and then I think we're going to be done. Just turn on all these layers again. Beep, 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 beep. Beep, 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 beep. Beep, beep, beep. Beep, beep, beep. Oh, I don't want the fabs on. The fabs are very verbose. You don't need that. All right, so I had a bunch of errors here. Right? These pads are all too close to each other, okay? That's just the way the footprint is. So what you do is you have to go to the board house that's going to make the circuit board for you and find out what the tolerance is. Once you find out their spacing, their minimum spacing requirements, you can go to board setup here and then put those new spacing requirements in. DRC is really important. You don't want to just pass DRC for the sake of passing DRC. You want to make sure you're staying in with the requirements, or else the cost could go up. All right, so what I'm going to do is I'm going to hit I already looked it up. It's 0.15 millimeter clearance for the board house that I'm using. I'm going to hit OK. Oh, whoops. I don't know what I just did there. Oh, I just selected I just selected a wire. Now I'm going to go back to DRC. I'm going to go run DRC. Hit refill. So it's going to refill all this. It's going to reevaluate the changes of the copper. And you see that I have no problems. List unconnected. Nothing. Boom. All that. Looks great. Close. This is ready to go and be sent out and be shipped and produced. Now, that's not really true because what I got to do is I have to move everything away from, I have to tuck things away. So if I did this, Lord knows that'll happen. It's going to break all kinds of stuff, so I got to have to break things and route things. When you're making a circuit board, you want to place things optimally and then route. I made a little bit of a mistake, but I can fix this. It's not a big deal. That looks like I can make that work. Yeah. So I got to do some geometry here. Sit tight. This guy's going to get done. We'll be one step close to the AmeriChete, and then I think after that, it's going to be time to use this with a Cypress dev kit and light the thing up. And it'll be really exciting to see. But we'll do the firmware after we've troubleshoot the board. Boards can have problems. Sorry, little voice crack there. Boards can have problems, and we're going to have to troubleshoot those problems, make sure that we're good to go and that we're meeting our hardware spec. All right. Boom. This has been fun. One step at a time. Notice how all of these are just like 1 hour or 15-minute sessions. I probably spent about 2 hours laying this board out. I wasn't really paying that close attention either. I was just listening to the radio and moving this thing around. Circuit boards are called artwork for a reason. You just sort of sit there and you make it work. You route things where they need to go. The computer has already knows where everything is supposed to connect, so there's no need to think about connections. And there's a DRC checker to make sure you haven't broken any rules that's going to make your board house unhappy. So it's really just about laying stuff out, making stuff pretty, making good patterns, making good decisions. I got to put a label on this thing as well. I have to put the title, my name, or at least my initials, the date, the revision, the title of the board, that sort of stuff, just for my own sake, just so I know what this board is when I look through my file of hundreds of boards a year from now or 2 years from now. All right, this has been the Alex Manassa. Hope you enjoyed it. I'll see you guys later.